Hi, and thanks for joining us. My name is Dan Gordon. I'm technical evangelist for Traceable, and this is Dancing with the Devil, API hacker versus Traceable. Thanks for joining us, Alissa, who is our...
Yeah, just to clarify, I'm the devil, not
I was
Traceable.
about to say, the devil, right?
I want to eliminate any questions. Hello, interwebs, everyone. I think all of you know who I am. Alissa Knight, reformed, or I should say recovering hacker, and with a specialty in hacking APIs. And
Well,
author of this paper.
And
That's important.
Thanks for agreeing to talk with us about it. We definitely want to hear more and share what you did and what you experienced and how it turned out. So, just to set a little context, let's talk for a minute about why APIs. Why are we looking at this? And I'll start with just saying, I think just recently and continuously we keep seeing, pretty big data breaches from pretty big companies that have pretty good security companies groups with them, and some of the best folks and some of the best tools to secure their applications. But we're still seeing things like the recent T-Mobile hack, right? 37 million records. So it's clear, I think, that APIs are, one, being used everywhere for everything, but two, we're not quite yet at the point where we're systematically securing them as much as we should, which I guess to an API hacker is news to your ears, right?
Field day.
So I guess one of the challenges that we hear when we talk about API security a lot is people say, well, I have a WAF or I have an API gateway, so I'm good, right? So as an API hacker, can you give us some of your insight into why that might not be true?
Yeah, so, as you know, just from previous research I've published with Traceable, like the price of hubris paper, when you secure something with the wrong tool, I feel it's actually worse than not having any tool at all, because you have this false sense of security, right? When you're trying to secure APIs with a web application firewall, to me, it's like trying to nail in a nail with a screwdriver, right? Instead of a hammer, using the wrong tool for the job. And so, I think, unfortunately, we as humans have a tendency to go back to what we know. And for decades, right, what have we been using to secure anything that speaks HTTP protocol? We've used WAFs. A web application firewall should be used to secure web servers. And I feel like that's sort of brought us to where we are right now, where system administrators, server administrators, whatever, are and security teams even are going back to what they know, which is, hey, look, APIs speak the HTTP protocol, and therefore we should secure them with what we know, which is a web application firewall. And so I feel like that's the reason behind so many API breaches right now. If you look at a lot of the research that I've published recently over the last decade, a lot of these research reports talk about the fact that a lot of these organizations where I was able to successfully breach these APIs and exfiltrate data, whether it was healthcare APIs or connected vehicles, were secured with WAFs. So I really feel like that was a big impetus behind us kind of coming together and deciding that a paper like this needed to be done, was because I wanted to talk about the efficacy of application programming interfaces, API security solutions that are purpose-built to secure APIs, and how effective they are at doing it.
But Alissa, I added API rules to my WAF. Isn't that enough? Right. I mean,
Well,
that's what we hear, right? So
yeah, I mean,
you
if
see
you
that a lot out there too. Hey, I have a WAF, we're a WAF, but we have
yeah.
API rules, so you're good to go, right?
I mean, you can employ, what I'll call legacy, web application attacks like SQL injection, cross-site scripting. You can employ those against an API. But the problem with web application firewalls is they really don't give you that context. They don't have that context in security, right? So I'm a big believer in the fact that without context, you don't have security. Application API security solutions like Traceable that are built from the ground up to secure APIs, understand business logic attacks. They'll be able to detect things like that. Whereas web application firewalls are rules-based, work off of rules-based languages. So it's known knowns. You're looking for known knowns. I know that this is bad and this is what I need to look for. The problem with that, as we saw with legacy network intrusion detection systems like Snort, right, Suricata, they use signature databases. They're looking for things we already know are bad. And so they're not going to detect things like zero-day attacks unless it's detecting something like shell code or command and control traffic of things that we already know, right, that are further along in the kill chain.
And the challenge with API. Oh, sorry. Go ahead.
Oh, sorry. No, I was just going to say, and with when you're hacking APIs, like a lot of the APIs, whether you mentioned T-Mobile and a lot of the other API breaches, a lot of the breaches we have found that the organizations came public about was that a lot of them were authorization-based vulnerabilities, where something like a web application firewall isn't going to be able to detect something like that. So if I'm logged in as Alissa Knight and I'm presenting to an API, that API endpoint, my token, and I'm requesting the bank account information for Dan Gordon, the web application firewall is going to be looking for known bad patterns. It's not going to know, well, Alissa Knight's logged in. Why is she requesting data on Dan? It's a web application firewall isn't going to be able to detect something like that, right? It's looking for things like SQL injection or
bad. And then on top of that, right, APIs, because of the way they work, they make up the business logic, and they are reasonably unique for each application in each organization, which means that the way that they come together and the way that you can attack them kind of differs or looks different almost every time, right? So you have a larger number of unknown type attacks, like almost every business logic attack from APIs is unknown, right?
Yeah.
So go ahead.
I was just gonna say, and that's a great, possible segue. And sorry if you're going to bring this up, but that's another reason why so many organizations get into so much hot water, so much trouble when they don't know what they've got deployed out there, right? You can't secure what you don't know you have. And so, that's another big part of the problem. And when you're using a rules-based system, let's take even network IDS, for example. You need to know your home net. You need to know what's behind that system. And so that's another, I'm sure, an issue you're going to bring up today, which is shadow APIs, and the fact that if you don't know what you've got running out there, or even what kind of data it's serving, it's really difficult to build rules around that, right? So not only just trying to stay ahead of the attackers and trying to figure out, what attack are they going to, employ next, and do I have rules for that?
What do you need to protect, right?
Yeah, exactly.
Yeah, that makes a lot of sense. So let's switch gears. I'd be curious to hear, I'm sure everyone, why this research? Why the head-to-head?
Okay, so
and with us in particular, right?
Yeah,
I'm sure you're getting asked by a lot of folks to challenge their
head-to-head with my product. Yeah, it's a common request. So here's the thing. It's no secret that in the research that I've been publishing over this past decade around hacking APIs, and as you know, just as well as the public knows, I've published vulnerability research with a lot of API security vendors. The reason why I wanted to do this was I wanted to really continue to fly the banner that I've flown in my career, which is does the product do what the marketing material says it does? That's such a big thing, right? So many organizations, so many vendors have gotten black eyes, gotten in trouble for saying they, zero false positives, or they are unhackable, and they've gotten in trouble for that because someone, calls zero love or whatever. But and so for me, it's always been very emblematic of my research to say, okay, the idea, this term that we coined at Night Inc., which was adversarial content, meaning content created by an adversary where you could see through the lens of the hacker, see through the lens of the adversary, was that we were proving that the product does exactly what the marketing material says it does. And that was the big reason behind this research. And you guys were kind enough to agree and think that this was going to be cool research. And so we moved forward with it. But,
Let's go. Yeah, absolutely.
Yeah. we believe in our product. And that says a lot about you guys, right? So, it's you guys, eat your own dog food, right? So, you believe in what you've made and stand behind it. And so that was a big reason behind this research was, hey, look, can CISOs trust this? Can organizations trust this solution in front of their APIs?
Well, yeah, absolutely. And we've also, we think we've got a different way of looking at this foundationally with the distributed tracing. And that we're pretty confident that makes a difference in our ability. So it was great that you're willing to give that a go. So
yeah, for sure. Yeah, it's very unique, right? So if you look at the other API security vendors, everyone knows it's public knowledge that there's different API security vendors out there. They each having their own approach to API security. I think for me, that was another thing that was very appealing to me about this research was I walked into this really not knowing much about distributed tracing myself. I'll call myself out. I had no idea how to even spell it, kind of thing. So for me, I had to research what distributed tracing was in order to even really be effective at this research. I wanted to understand, how does Traceable tick? What's its secret sauce? What is this distributed tracing I keep seeing, and how does it work? So as an adversary, I can figure out how to get around that. Can I evade Traceable?
Mm-hmm.
How does distributed tracing work? Is it something that I can, for example, adversarial machine learning, adversarial learning, can I retrain it and tell it to not see me, or not detect this particular attack? So I think, much to your point, that was a big reason for me. The big impetus behind specifically Traceable was because you guys keep talking about distributed tracing capabilities, and I wanted to understand what made that different or better than the other solutions.
Sure. And if I may, for the audience, just a little bit on that, you had in the ebook a really a nice analogy on that, and I'll encourage everyone to grab the ebook to check that out.
It's good.
But it's this notion of like the air tags, right? And you can have it show you every step, like you went from here to here, from here to here to here to here, so you can figure out what the not just what the destination is, but like what happened along the way. And that's in a sense what really distributed tracing does, is we track the transaction from the time the user connects to the to all the way through the systems, through the back end, and all the way back again through the many microservices network, etc., so that we understand not just the single communication, but the whole context of it, and what happened. And along with that, the kind of the unsung hero is really the collection of the right set of data from that, right? Yeah. Because if you track everything that's happening, but then you throw away all the context and you're just left with the problem, then you really lose the ability to really dig in and find out contextually what's happening and what led up to things, and to do forensics and threat hunting and root cause analysis. So one of the things that we do differently that I think makes a difference, and we'll see, is the distributed tracing, but then also how we capture that data and what we do with it. So enough of that, I guess. So if we switch to the research now, this paper, this ebook, the research you did, tell me about the test set, the OWASP lists that you used. Why those, and yeah, what's the thinking there?
Yeah, so we as an industry have decided collectively that OWASP was the single source of truth, or the reference model, if you will, to what should we be expecting at our front door from the adversary as far as the types of vulnerabilities that are being exploited out in the wild. And thus was the OWASP top 10 list, right? The top 10 vulnerabilities that you need to look out for in protecting your web applications. Now, later on, we've now seen this new project, which I recently just became a contributor to, which is the OWASP API Security Top 10. This top 10 list is the top 10 vulnerabilities that are commonly seen exploited in the wild of APIs. And so I chose the OWASP API Security Top 10, making a difference there, and also the OWASP Top 10 for the two target sets, right? For something that we could rinse and repeat over and over, depending on how many times we needed to run the test to make sure that that test was the same every time. And that way, anyone who wants to really kind of say, okay, I want to be Alissa Knight, I want to walk a mile in her shoes, what test did she run? You know that I've used this industry accepted, industry standard list of top 10 vulnerabilities, which is the OWASP list.
Yeah, list. It's hard to say that. So the OWASP list. So yeah, so I mean, it makes a lot of sense, right? Given that the industry is kind of settled on that, and on those lists is like, hey, this is what we're really seeing. OWASP has done a great job, both for both the lists of identifying, capturing, and really updating those. Right. I think the top 10 list, the web top 10 list, we call it, just got a refresh a year or two ago. And there's a new one coming out soon for the API top 10, security top 10. It says something, I think, that this organization that everyone respects for web security, having a list already for web applications, realized that they needed to have an API specific list because
Right.
and we talked about this a little bit earlier, but because APIs are different, and the API vulnerabilities and the way to exploit them and the way hence to protect them are different than what you do for web, the more traditional web application attacks.
Which begs to ask, why are people still trying to secure their APIs with web application firewalls when OWASP, whom we all trust and our go-to as an authority in this, has a completely separate list for APIs and API vulnerabilities? It should say something. I feel like it speaks volumes.
It does indeed, and that's a little aside that the WAFs are primarily based off of the original list, the web top 10 list, right?
Right.
So cool. So okay, so we're gonna set some stuff up, and you're gonna attack it, and we're gonna look at the results, right? So that was the thinking here. So how did you make sure this was a legitimate test? Like, what was your control? How did you make sure that, like, that you're getting good data?
Right. So I want all of you in the audience who's watching this to know that we really wanted to maintain as much of a bright line or separation of duties here as possible to make sure that I, acting as the adversary, wasn't touching the build, I wasn't touching the lab, I wasn't responsible for setting up and installing it. So a good friend of mine and colleague, Chris Daniels, worked on the blue team side while I was the red team, right? So he was responsible for logging into Traceable. He was responsible for building out, installing JuiceShop and crAPI, and I didn't have access to that. So there was no opportunity for me, not that I would, but in this particular engagement, the rules of engagement for this was that I didn't have access to that backend to be able to manipulate the results of this testing in any way.
Until afterwards, when we showed you your trail that you were leaving. So we didn't. Look, that's you. We didn't mention that, but you just brought that up. So thank you. The applications.
Yeah. So yeah, we should probably talk about that. Okay. We all understand that JuiceShop is not an API. It's a traditional web application for testing the vulnerabilities in the OWASP top 10 list.
I mean,
Okay,
it has some APIs, right?
it has some APIs, yeah, but I mean,
it wasn't designed
how
to
do
be
I
an
say,
API.
it wasn't designed for an exercise like this. It definitely has way more vulnerabilities, but we as a
great
secondary,
project. Absolutely.
yeah. And I think it's a lot older than crAPI, right? So, so crAPI being a newer project, and also crAPI being very niche in the fact that it was designed from the ground up to be a vulnerable API, thus the name crAPI. So
completely ridiculous API, in case anyone's wondering.
By the way, great name. And all of you can go out and download it. It's for a free GitHub open source project. You can go download that, and allow you to test. It allows you to test your skills and exercising your skills and capacity building and hacking APIs. But the reason why we wanted these two separate targets was because of the fact that I wanted to also put the pedal to the metal on Traceable in its claim that it also can detect traditional web application attacks. So I thought, in all fairness, let's test both, right? Which is probably why so much time was spent on this research project. Why not?
You're using automated scripts anyways, right? So,
if we're in there, we might as well. That's the reason why, for the two separate test beds.
So you tested that you could get into these that you could take advantage of these vulnerabilities and get into the apps first, and then
yeah, so there were two separate I would call them phases, probably. Phase one was, let's test the vulnerabilities, let's figure out how to exploit JuiceShop, let's figure out how to exploit crAPI, let's find the vulnerabilities, and figure that all out. So that took a lot of time as well, and so we figured that out.
Sense, right? You got to make sure that you can get in before you see if
you're like, can I hack? Because you don't want to start out in a research project like this with the security control in place, because then what if
how do you know what's going on, right? Yeah. So.
What if Traceable actually does what it says it does and actually blocks me? It's going to be really tough to figure out if my exploits are working.
You can tell if it doesn't, at least. So.
Yeah, right away. Yeah. So that was the reason behind that. So we wanted two separate test environments and make sure everything.
So how about so here's the part that probably people want to hear about, right? So, all right, you do a lot of hacking of APIs. What are your go-to tools? What do you use for this?
Let's point the pink elephant out in the room. I mean, we all know. I mean, this is a very sexy, exciting, newish area of penetration testing, right? I get a lot of messages on LinkedIn and Twitter saying, "Hey, look, I'm really excited about API pen testing. There isn't much content out there on this, and there seems to be kind of like this, what's groundswell." Right, of people just kind of migrating over to wanting to learn how to do this, learn the tools that are out there. There's a great mind map out there created by a gentleman named David Sopas called the Mind API Mind Map API hacking. So what he did was he broke out all the tools in API hacking and gives you links to them depending on what part of the kill chain you're in hacking APIs. So go take a look. It's a great project. But me personally, for my attack stack, if you will, I use a combination of Postman, Burp Suite, and depending on the type of engagement, like if I'm doing a woman in the middle attack, I'll use something like MobSF to do static code analysis, dead code analysis, and also dynamic code analysis. And also, if I want to insert myself in the communication between the mobile app and the API, and there's encryption going on, I'll use something like Minim Proxy. You can also use Burp Suite, but Burp Suite being kind of more of the Swiss Army knife, if you will. Instead of having this big stack of tools, you can just have Burp Suite. And I'll be demonstrating that today.
Cool. Yeah, matter of fact, I think we should move to that at this point.
You want to jump into it? Everyone's like, come
on. Show them what you did. At least a little bit of it.
Yeah. Okay, so I am right now showing all of you my screen here. So over here on the right-hand side is actually Chromium, which I love this about Burp Suite. For those of you who are not aware, Burp Suite actually packages Chromium with it. And what it will do is it will actually give you all of the packets right there in your proxy tab under HTTP history. So if you want to intercept any of the API requests and look at them and manipulate them, and it's a web-based API, remember, you have different types of APIs, everybody. You have, you have web APIs, you have mobile APIs, but if you're dealing with a web API, your number one question might be, hey, Alyssa, you use these other tools for mobile APIs, but what if I'm dealing with a web API? Well, Burp Suite is your friend. And within Burp Suite, under the Intercept tab, within proxy, have this button.
So sorry, before you dive into this part, which exploit are you gonna show us first?
Yeah, so I'm just kind of quickly going over the tools I'm going to be demonstrating, but I actually use Burp Suite for both of the attacks.
Okay.
And I'm also going to combine Postman in there as well. But within the Intercept tab, you'll have this open browser tab, and that will open Chromium. Now, right here up here is the URL for the crAPI installation that we're targeting for this demo. And when you log into crAPI, the first thing that you're going to see is a list of all the vehicles. I'm going to place a couple orders here. I'll buy a seat, and let's buy a wheel. So we've got some orders in there. Don't spend too much money. All right, and so now here in our HTTP history tab is all of our packets. Now I'm also going to be combining Postman. Now one of the first attacks that I'm going to be showing all of you is BOLA attack, which is broken object level authorization. And I give an explanation of what BOLA attacks are in my paper, but for those of you just really quickly, it's basically exploiting a flaw in a failure to authorize the API request. So I'm authenticated and I'm giving this OAuth token, but the API isn't properly authorizing me. Now here in this example, let me just kind of show you my variables. So within Postman, I think one of the really cool things about Postman is it has this concept of variables. So I've created what's called a Postman collection here with all of the attacks that I levied against crAPI. Now under the BOLA folder of scripts, I've got a request that shows me all of my orders of the logged in user, and then get a specific order. So this is actually calling two variables, and that's the URL and the order ID. So for the URL, I just pasted the URL here. I also put in my bearer token, which I got from Burp Suite, and that's right here, everybody. You can see my bearer token. And I pasted that into my variables tab. And pull that back up. Sorry. And then pasted the order ID, right? So here, if I send this request, it's going to show me all of the orders within crAPI. These are all of my orders that I've placed, which isn't a vulnerability, right? It's just showing me
placed, right?
Yeah, that I've placed. Yeah, let's make that abundantly clear. These are my orders. All right, so you can even see in here, you can see the wheel that I ordered. You can see the, my email address and phone number, fine, whatever. And then, so
what area code is that? No, just
joking. But here, underneath each order ID, what is this giving you, everybody? This is telling me the syntax of the order IDs. If I'm going to attack this API, I want to know how the API works, right? I'm always telling you all that in my tutorials. Hacking is nothing more than just sending stimulus to an application that the developer didn't expect to receive. How can you do that? How can you hack an app or an API if you don't know how it works first? So, let's pull a list of orders. So this gives us exposed object IDs, right? So we've got some exposed object IDs here. Now, what I can do is if I want to look at a specific order, right? If I want to look at my orders, this is sending a specific request. We can just see that without even going into Burp Suite. We can see that URL right here, orders ? order ID 301. But what happens, now let's get in our attacker mindset. What happens if I send an order ID that doesn't belong to me? What happens now that I know what the order ID syntax is, now that I know what schema, if you will, that's being used, I can now go into the get order specific API request and specify an actual order ID. So let's say I want to look at order number. We can see here, let's go to get orders. We can see 300, 301, 305, 309. What if 310? So we know that the most recent order I ordered was order number 310. What happens if I send one for order number 1? Just order number 1, right? We clearly, you guys and girls, you all saw that order number 1 is not one of my orders. And look at that. We can pull up the order information for any user within the system. So that's a BOLA attack, broken object level authorization. So I can go in here, and another poor coding mistake is putting your object IDs in sequential order. So here you can
poor enumeration, and then, oh, by the way, putting them in the URL, right?
Yeah, exactly. Yeah, don't expose them in the URL. That's definitely another bad thing. But you know, you can see here I can just cycle through all these objects. So next, now that I've demonstrated the BOLA attack, I'm going to do another type of attack, which is called an XXE attack, which stands for XML External Entity, XXE. And yes, I did have to Google that. We have way too many acronyms in cybersecurity. So we have the different XXE attacks here. I've created scripts for. And XXE is basically just calling, in this particular example, I'm trying to call it Etsy password, right? So I can go ahead and send this over. Let's put all those through. All right. So now we've done 2 types of attacks, everyone. I just want to kind of walk you through this again. First, I did a BOLA attack. I did some enumeration, figure out how the API works. But we did a BOLA attack, and then I sent several, not one, but several XXE attempts just now. So now that you've seen it from my attacker side, let's show it all from the defender side, from the blue team. So Dan, I'm going to pass the stage back over to you, and let's see what Traceable saw.
All right, so we're looking at the Traceable interface, and in this particular case, we're looking at the events. And let me do a refresh here, but we can actually already see the, there's the XXE, the BOLA, we call it authorization bypass, user level and object level. And so that was around, 6607. So let's take a look at that real quick.
And Dan, do we want to let the audience know that the reason why my BOLA attack was successful is because you haven't turned blocking on, correct?
Right.
Just so,
yeah, we're just letting this,
wondering why
we're letting this go. So
yeah.
we could get the full thing here, and we could see we've picked out the user. Right. This was Alyssa's login during this, and the API endpoint she hit, the service that was hit. But let's go look at more detail on it. And this will give us, first of all, the information about why it thinks this was a BOLA attack. And all the details about that, including, here's that bearer token that she used, the information that was sent and the response that was sent that came back. And what we're seeing here on the right side is the what we call the kill chain, right? These are the API calls that Alyssa made on the way to the point of the attack, so we can understand the context of what happened. And from there, we can actually look at the full session. So she's logged in and doing a bunch of things, usually more than one attack during a login session. And so here we have everything that was done during that session. And from that, we can do things like see if there was any personally identifiable information that got grabbed. So it looks like on pretty much a lot of it. And if we look a little deeper at that particular one, then we can see here's what was sent.
There's my body, yeah.
And there's the response with the body as well. So so the information is there. Let's go look at that XXE, and we'll get back to the threat actor in a second. Here's the XXE attack.
Oh, interesting. It also caught my cross-site scripting attacks I sent earlier as well.
It did, yes. So similar thing, here's what we found. Here's all the headers and footers for the response. The request and response, the headers and footers, the headers and body, as well as the kill chain, including access to even what we call the traces that go deeper into all of the calls that happen, not just the APIs that were called. And then we can also get into, for example, the actual detail about that particular API endpoint. So we can see, for example, the generated OpenAPI spec, the malicious behaviors that went up against it, the parameters that might have been manipulated, and all of that great information. So that's part of the catalog, and that all connects back so that we can understand the attacks that are happening and how they might affect us and how we can secure against them. So one of the things I mentioned I'd point out is we're tracking everything Alissa was doing, not just individual attacks, but she's got a record, right? She's been, obviously, as you can see, doing quite a bit of stuff here. So
not the only record.
Look at you. And so here is everything that she has done against the system for, over time, over sessions, and we've assigned, of course, each one has its own level of criticality, and you can see we've rolled up, right? There are several, there's actually 2 here and a bunch here, so that it's a little easier to consume. But we've also, the system is basically ratcheted up. So congratulations, you've made critical. You've got a threat score of 91. We can have the system automatically shut you out, which we did in some of the instances during the research. And then we were like, okay, we got to let you back in so you can keep going, right? But we can also manually do that, right? So at this point, that's it. You're done, right? You're on the deny list. So the system's going to block you out when you try and do anything.
That's pretty fast too.
And so that's kind of the blue team, or our side of it, and what Traceable was tracking while Alissa was poking around and trying to do things. So let's switch gears back then. We just saw all of that, and that went on for a while, right? That was just 1 or 2 attacks, and we had a whole list of them, right? With the at least 20, right? 2 top 10 lists. So what was the result? Maybe you could share with us and kind of spoil the paper for everyone.
We really, spoiler alert, stop here if you don't want to know what happened. Yeah, so Traceable was successful in stopping all of my attacks. It was pretty interesting because I have done similar exercises to this with other solutions where it didn't see me every time. And the interesting thing here, and I'm going to drop another spoiler, we did actually attempt to do evasion. So there are sections of the paper. I would really urge all of you to go download. It's a free download. You don't have to pay for it. I do urge you to go download it, because the interesting thing about it is there's the section with some of the attacks where I did attempt to evade Traceable, and gave you the results from that. So again, as an adversary, you're wanting to obviously go after the softest target. But if you are really intent on being able to get in, depending on the target, then you're going to try and evade whatever is trying to block you or stop you, hoping it's a WAF, right? My biggest hope with any API is that they're running a WAF to rely on for security. So if you're using that, then I'm coming for you. No, just kidding. But is to always really to try and move on to the softest target. And so at this point, there was such a disruption, at least in my adversarial decision making process, where I was like, look, I would have just in a real world situation moved on to a softer target. But it was successful in identifying every single one of my attempts to exploit the API. It did block me when we put it in blocking mode. So from my perspective, my opinion, is that it does what it says it does. It's my review of the Traceable solution is I'm hoping that whatever API I'm up against next isn't using it.
Great. That was a good outcome, and that was not a preordained outcome. So, so
I didn't. I actually, I mean, obviously, I've been doing this for 23 years as a hacker, and obviously, my intent to walk into this is to try and either get around Traceable or it to not do well at identifying me or stopping me. And so, it is a pretty big blow to any hacker's ego when you're like, I can't get a shell, or I can't get this data, or I can't do this. So yeah, I
like
definitely,
you said, you move on to a different target, right? So,
what did they say about hackers? We're arrogant, right? I'm definitely one of those. I definitely, you pulled my card on that one. It's like, I'm walking into any exercise and you're like, oh, I'm going to get in. I'm, got all the time in the world, sort of, and all the efforts and resources, and knowing that I don't have to worry about, getting arrested or anything like that. This is a sanctioned test. So,
right.
I can do whatever I want for as long as I want. And so obviously walking into this, my hope is that I would succeed and not fail. And in this attempt, I actually failed.
Well, thank you for being vulnerable about that, and willing to take, to go up and work with us on this.
You win some, you lose some. It's like for any pen testers in the audience right now, you're not gonna get a root shell or whatever on a domain admin on every single pen test. There's gonna be times when there's a lot. They have effective security controls in place, and so I would definitely give 2 thumbs up and recommendations on using Traceable to secure your APIs. It works. It does what it says it does.
Well, thanks. We're certainly happy to hear that. Thank you for your time and sharing with us on this, and everyone in the audience. Thanks for your time to watch this and to hear it and to take the journey with us. Do please, as Alyssa's mentioned, check out the paper. It is on your site and it is on the Traceable site. And come learn more about Traceable. Ask us questions. Get more of a demo. Find out more. We'd love to talk to you. So again, thank you very much.
Thank you so much, Dan. It's been fun. It's been an awesome ride, but it's been a journey for sure.
Indeed it has.